folks. Well, so far everything we've been doing for input and output has been with printf and scanf from the csci.viu library. This time around I want to take a look at the more C++ way of doing things, so using the iostream library and cin and cout. Now, there will be occasions when I specify, you have to use this one or the other, just because I want people to be basically familiar with both. But when it comes to doing most of the things like the project and a lot of the labs and a lot of the other exercises, I'll let you pick whichever one that you want to use. So let's dive in and have a bit of a look here. So I want to run through kind of the big differences that we're going to encounter. So the input and output routines will be cin and cout, and they are quite different syntactically than scanf and printf. The behavior is similar in terms of how they handle white space and how they produce output on the screen. It's the program syntax that looks quite different. I will talk a little bit about namespaces because we are going to encounter those once we introduce the iostream library. We'll get into the basic use of cout and an alternative option it gives us for displaying new lines instead of the \n. And then we'll get into simple input with cin and a little bit of formatting. So we'll bring our cout and cin to about the same spot that we're at with our handling of scanf and printf. All right. First, I want to talk about namespaces because this is going to crop up. C++ allows you to take collections of definitions for variables and functions and whatever named items you might have and group them together into namespaces. And then you can say, I want to use, in your program, you can say, I want to use the set of definitions that are provided in this namespace, or I want to use the set of definitions that are provided in this other namespace. And again, it just allows us a way to group a bunch of definitions together and say whether or not we want to use all of the ones, or if there's different definitions for something in different namespaces, we can go through and specify, okay, I want to use the definition of this that's provided in, namespace X. So that's about as much detail as I want to get into for now on it. We will come back and visit namespaces in more detail later, but just to give you kind of an intuitive feel for the purpose of these things. So when we include the iostream library that's got cin and cout in it, they're defined as part of one of these namespaces. So this particular namespace is called std for standard. So we're going to say whenever we use our iostream library for now, we're going to say we're using the namespace standard, std. So this this technique has some disadvantages in that it's telling us that we want to use everything, or we want to have all of the definitions from that namespace available, but we'll come back and talk about alternative ways to do this again later in the semester once we get into talking about namespaces in some detail. For now, we'll just make sure that we include our iostream library, say we're using the standard namespace, and proceed from there. So we want to get into output first off. Right, so there's a routine called cout that's part of that iostream library and part of that std namespace. And again, the syntax, as you'll see in just a second here, is quite different than with printf. So when we want to print out something with cout, we use cout and then the two less than signs and then the thing we want to display. So it can be a text string, or it can be a variable, or it can be a constant value. So here, for example, we've got an integer variable x, a floating point variable y. Let's suppose that we had actual values in those. And then we say cout, and again, our two less thans, here is x, so that would come out as text. And then whatever the value of x is, and the nice thing about cout is it figures out the data type for us. We don't need, %fs or %ds to specify what kind of a thing it is. So it just prints out whatever the value of x is, and then we can throw more text in if we like. And again, we're just putting a less than before each of the things that we want to print out. Right, so all of this stuff at the moment is just going to come out on one line. We'll look at new lines in just a second. But we can put together our couts that way. Again, as always, remember we throw in our semicolon at the end. But it gives us kind of the behavior that we want. So let's try that out just briefly. So we'll say I want to use iostream. I want to use the namespace space std for standard, my int main. Let's create an integer variable x, and I don't know, we'll throw 12 in there. Let's create a floating point variable f and throw 1.234 in there. And let's just try printing it out. You know, x is, let's do these on, we'll do our couts in a variety of different ways here. So let's say x is, and then on the next line, we'll print out x, and then maybe we'll say, we'll throw a comma. So again, anytime I'm throwing in text, cout is just putting one thing right after another. So it's going to say x is whatever x is, and then a comma, space, you know, y is, and a space there. And let's, again, just to show different uses of cout, we'll throw in the y. All right, so you can get just this combinations of outputs. So let's do our compilation. We want to compile output.cpp. Let's call our executable, I don't know, outx. I'll turn on my warnings while in Wextra. Let's see how we go. Oh, printing out y when I called it f. How about we fix that? And okay, it seems to think it compiled okay, so we'll try running outx. And again, it does our x is 12, f is 1.234. We haven't put any new lines at the end of this yet, so that's how come the prompt comes out on the same line. So let's go back and talk about new lines. So we could go through and use new lines like we did with printf in throwing a \n into a double quoted string. That'll work just fine. But the iostream library also gives us a named value endl that also throws out a new line for us. So let's compile again, and let's run it. And so this time, whoops, I should play with my formatting a little bit. We threw in a new line after printing out x is 12, and we threw in an endl after printing out the f is 1.234. So let's just get that comma fixed up there. I guess if we've got a new line, we probably don't need the comma and space. So let's compile again and run again, and there we get the behavior. So you'll see that throwing in the \n or throwing in the endl gives us more or less the same behavior for now. There are some other subtle differences, but we'll worry about those later. You can chain as many of these endls together as you like to create blank lines in the output. Oops. So that first endl ends the current line, and then that one throws in another new line, so we get one blank line, and then another one, so we get two blank lines. And we try running it, and there you go, you get your two blank lines in the output. So that's the essence of cout and the notion of endl as an alternative new line approach. Now, for the other way, for reading values in, we had scanf before that would wait for the user to type something, read it in, stick it in a variable for us. We'll use cin to do the same thing. So cin is also part of this iostream library, and it's placed in the std namespace. And it uses a greater than, so kind of think of them as arrows going the other direction. All right, so for the cout, it was cout, and then arrows pointing towards the cout to send output. For cin, it's kind of pointing from the cin into a variable. So we can create a couple of variables, and then just use cin and the greater than, and the variable you want the next user-typed value to go into. And again, the nice thing about cin is that it looks at the data types for us. We don't have to specify %fs or %ds. We don't have to use that ampersand to indicate memory addresses or anything like that. It's just cin, the greater than, and the place we want to store the value. So let's go back and try editing our output again, only this time let's tweak things a little bit. And well, actually, let's just redo this. So let's create a couple of variables. So we'll create a variable, our integer variables x and f still. Oh, let's use x and y, so otherwise I'm going to forget again. So we've got our variables x and y, and let's use couts to say, you know, please enter an integer, and we throw in an indel, and then we'll read whatever they type in response into x, and then we'll do something similarly, you know, please enter a float, and we'll read that into y, and then we'll try printing them out. You know, now x is, and whatever x is, and y is whatever y is. So we'll try compiling. Seems okay so far. We'll try running it. And again, it says please enter an integer, so we'll have, I don't know, 54. Please enter a float, 0.001. And it turns around and tells us, okay, now x is 54 and y is 0.001. So we can get basic input and output going as well. You can chain these things together with cin, so you could say something like enter an integer, then a float, and we could read them in and say, oh, well, read in an integer into x and then a float into y, and then we'll just print them out again. I'm just going to copy and paste that chunk there. And we'll try compiling and try running. Oh, okay, so we've still got our original stuff. So that was the first one where it read them in separately, and now it's saying enter an integer and a float. So I can say, I don't know, 600 is my integer. And again, it's much like scanf, it's sitting waiting for me to type the next value before it can read in that float. So I'll say, you know, 10.2, and it finishes and reads them in. And again, it read the first one into x and the second one into y because that was the order we placed them in. So we can play with cin as a way to perform input as an alternative to scanf. Just as a cautionary note, I strongly recommend either using iostream with cin and cout, or use csci.viu with scanf and printf. Don't mix and match them. Don't try and use both iostream and csci.viu and, you know, use scanfs and couts or printfs and cins or something like that. So pick one approach or the other whenever you're writing a program. All right, I just wanted to touch on a little bit of formatting, much like we did with printf, where you want to set either the width of something or you want to set the number of digits of precision for a float. So we'll just do setting the width first off. So there's a separate library that we'll need for this one. It's called iomanip, right, for manipulating your input and output. And again, it's using that standard namespace. And that provides us with a set width routine that tells us the total width we want for the next thing that's being displayed. And again, much like with printf, it pads it out with spaces to take up that much space. If it already takes up that much space or more space, it just ignores the set width. So set width 6 is going to pad whatever the contents of x are to 6 characters, or at least a minimum of 6 characters. So let's try that in our example here. So we'll try our iomanip. And let's, here I'm going to reduce the amount of typing I have to do when we test this. So we're entering an integer, we're entering a float. Let's try a couple of set widths here. So we'll try setting the width of X to 5, and we'll try setting the width of Y to 7, not for any particular reason, just to try them out. So pad X to at least 5 characters, Y to at least 7 characters. So we'll compile again, and we'll run the beastie. So I'm going to enter 123, so it's going to pad this to 5 spaces, so it should throw 2 spaces in front of the 1, 2, 3. Please enter a float, so let's go 1.234. And again, it's going to pad this one to 7, so it should be throwing 3 spaces in front of that one. And there we've got the padding taking place. We should probably make the output a little clearer so that we can see those spaces. Oops, see those spaces a little better. How about let's try this. We'll throw in an endl, so the value of X goes at the start of the next line, and then we'll do the same thing with Y. So now X is, and on the next line it'll print X padded to 5 spaces, and Y is, and on the next line it'll print Y padded to 7 spaces. And again, let's try 123 and 1.234. And so we've got 2 extra spaces added in front of the X to make it 5 characters wide, and 2 extra spaces added in front of the Y because we've got the 4 digits in the decimal point. So we've got the padding that we were expecting. All right, and I think the last thing I wanted to touch on here was specifying the number of digits after the decimal point for floating point numbers. So for this one, we've got a 2-step process. We're going to first, and these are both part of the iomanip library, we're first going to tell cout that we want to use fixed precision for floats. And so first we turn on fixed precision. And then after we've done that, anytime we want, we can specify how much precision we want for the next coming value. So it's cout, the less than, and the set ios flags, ios : fixed. So this there's an ios namespace in which fixed is declared, and that's when we're setting the ios flags, we're setting the io flags or iostream flags to include this use of fixed point is what's going on with all this notation. But this is how we turn on fixed point precision, and then this set precision routine allows us to specify for a specific value that's coming up how much precision do we want to use. So let's give that a try. I'm just going to ditch the integer part for now since we're interested in the floats. So we'll enter in a float, and we'll turn on our set ios flags, ios : fixed. And then let's say Y with 2 digits of precision, and we're going to print out, we'll print out Y with 2 digits of precision. So again, just whatever text prompt I want. Specify this time print it out with 2 digits of precision, and then maybe the second time around we'll print it out, with 3 digits of precision. So let's give that a try. Let's see what I broke. Oh, nothing. Oh. So let's enter 1.2345, and again it should print it once with 2 digits of precision and once with 3. And there we go. So again, this is much like the formatting that we were playing with in printf. It's just the quite different syntax to use for cout as opposed to our printfs. All right, that should have us to about the same point of I/O capabilities in both of the different libraries. Again, I will get you to do a little bit with each of them for, say, the quizzes, maybe for a lab somewhere in there, where I'll specify, okay, this time you have to use printf, okay, this time you have to use, or this time you have to use stdio, this time you have to use iostream. But in general, I'll give you the choice as to which one you want to work with. All right, I will leave that there.